Hi students, today we'll discuss one more new topic, that is rotational work or the energy associated with a rotational motion. I already discussed moment of inertia, angular momentum, torque, also already uploaded the video. Please, if you did not watch, no, please watch and come back here. No, we'll discuss all the possible different type of questions, no, so which are involved in the rotational work or power or energy. So we already studied work done in our translatory motion. Now, what is the work done formula? We written like a force dot displacement. Yes or no? So, or if it is a small force is there, no, right? F dot dr. So we already written now. Here force makes an object to translate, right? So which one will make an object to rotate now? We already discussed in the last topic, no? So torque will make an object to rotate here, right? So similarly, work done for rotating, to rotate any object, no, we have to do certain amount of work. The amount of work done can be calculated as, to rotate that object, no, we require the torque. Therefore, here work done, we can write down torque dot. How we are going to rotate now? Rotate means there is no other displacement, no, there will be only angular displacement will be there. So here we can rewrite it as like a angular displacement. Clear? So if it is a small amount of displacement is there, no, therefore W is equals to integral tau dot d theta. In this way we can calculate the work done in rotating any object, right? So here theta, so we can rewrite it as like a radians, no. So torque is nothing but a Newton meter, therefore SI unit is nothing but a joules. We already studied about this one. Clear? So work done, therefore work done it can be written as like a tau dot or torque dot angular displacement now. So we studied in our translator motion, no. So we studied work energy theorem. Work energy theorem. What is the work energy theorem? Work done by all the forces. Work done by all the forces. All the forces, conservative forces, non-conservative forces, no, work done by all the forces, no, will be equal to change in kinetic energy. That means nothing but a final kinetic energy minus initial kinetic energy, half m. So initial, sorry here, no, so half m v final square minus half m v initial square. So work done by all the forces, even conservative force, non-conservative forces, frictional force, any other forces, no. So this formula is applicable now. Exactly the same. So work energy theorem in our rotational motion, no, work energy theorem. So work done by all the torques, all torque, it will be equal to change in kinetic energy. What is the kinetic energy formula? Half I omega square, that is nothing but a final half I omega initial square. Clear? So work done by all the torques, no, so it will be equal to final kinetic energy, final rotational kinetic energy minus initial rotational kinetic energy. So we can rewrite it as kinetic energy formula. What is the kinetic energy formula? Rotational kinetic energy. So we already studied. So translational kinetic energy we know it, no, half m v square. Similarly, rotational kinetic energy, what is the formula here, no? Rotational kinetic energy. I already derived this equation in the moment of inertia concept, no? There we got it as I instead of mass, no? Here it will be moment of inertia, instead of velocity it will be angular velocity square. So sometimes you need to have conversion, no? Therefore we know that formula V is equals to R omega, therefore we can use this formula for any time the conversions onto this. Clear? And also we discussed the power, right? So here we discussed the power, no. What is the power formula here now? Power is equals to work by time, work by time. So therefore that is nothing but energy by time. So what is the unit now? We know that it is watt. So similarly, therefore here what is the power now? Power is also nothing but a work by time. So what is the work done, work by time now? Therefore here we can write down. So power is equals to F dot V. Clear? Similarly, here also power can be written as, so power can be written as work. Here instead of the force, here it will be the torque dot. Here instead of velocity, it will be the angular velocity. Clear? So power can also be calculated like this. So simple thing, no, in the translator motion, no, we use force and mass as inertia. So displacement velocities also. Here instead of mass we will use moment of inertia, instead of velocity angular velocity, instead of force here torque, instead of momentum here angular momentum, right? So therefore here the power is same, all these are now clear. So exactly therefore all these concepts, no, you can use it now. Therefore how we calculated the problems in our mechanics, no, therefore in our translator motion exactly we can do the questions related to this one, no, right? Also one more formula is there, no, kinetic energy formula. What is the kinetic energy formula here now? Okay, in our translator motion, what is the kinetic energy formula? That is half mv square. So I can multiply m and divide by m, therefore mv whole square by 2m. Therefore what you can write now, kinetic energy, it will be equal to p square by 2m. Clear? Similarly here this is translational kinetic energy. Here rotational kinetic energy, what you can write it now? Therefore it will be L square by 2I will be your rotational kinetic energy. This is your translational kinetic energy. Clear? L is nothing but angular momentum. Here P is nothing but a linear momentum. Here M is nothing but a mass. Here I is nothing but a inertia. Clear? So in this way, so therefore you can use these formulas, no? Then you can solve whatever the problems it is asked. And one more formula is there, no? That is nothing but a angular velocity. What is an angular velocity formula? 2 pi by t. That is nothing but a 2 pi into f. Clear? So it is in terms of frequency, right? So relation, no, we can write it as v is equals to r omega. And also we can use all kinematics equations, no? That is omega final, it will be equal to omega initial plus alpha into t. So therefore here theta is equals to omega initial into t plus 1 by 2 alpha into t square, and omega final square minus omega initial square 2 alpha into theta. One more important formula, number of rotations, number of turns. How to calculate it now? Number of turns is nothing but the total angle divided by, therefore it is 2 pi. In this way you can calculate number of turns, it is made it now. Number of rotations, it is made it now. Like that we can calculate by using this concept now. Clear? So some more problems now we will do related to this one now in the rotational kinetic energy. Clear? Right, students? Right, we will do the questions now. Please watch until the end. At last I kept like very important questions now, which are my favorite questions and which will be having lot of learning. So right, watch up to the end of this. Right, let us solve the questions onto this one now. What is this question now? Yeah, this is very simple question now. So here is asking, he gave angular velocity, he gave, no, and a torque he gave, is asking the power. What is the power formula? We written now, power is equals to, so torque dot omega, dot product. How to calculate the dot product? No, already we studied dot product. No, therefore torque how much? No, I plus 2j plus 3k dot, therefore 2I plus 3j plus 4k. Right? So you need to multiply the coefficients of I, and you should not have any ij here, right? So because power is a scalar, 2 into 1 2, so plus into plus plus only, 3 2 is 6, so plus into plus plus only, it is 12. Therefore how much it will be? So 14 plus 6, no, so therefore 20 watt. So first option will be your correct answer. Clear? We will do one more question now. Right. So we will do one more question here now. Let us see. Right. Here a thin a uniform thin rod of mass m, right? It is having mass m is there and length is L, suspended from one of its end and is rotated at a rate of f rotations per second. Find rotational kinetic energy. Simple concept, no? There is a rod is there, no, like this. So it is rotated like this, right? So what is this, no? He gave f rotation per second. See, RPM, RPS, rotation per second, rotation per minute. These all are nothing but a frequency, not omega. Clear? So therefore omega you can write it as like a 2 pi into frequency. Here f is given, therefore f. Clear? So we want to calculate rotational kinetic energy. What is the kinetic energy formula here, no? So that is nothing but a half I omega square. So half. This is a rod is there. It is rotating means what? Where is the axis of rotation? No, it is like this. That means passing through any one of its end. So these type of problems, no, I already solved in moment of inertia part 2. So I will keep it on the iCard, no. Please watch that video. So therefore, moment of inertia of a rod, an axis passing through any one of its edge is nothing but a ml square by 3. Therefore, ml square by 3 into, therefore omega is nothing but a 2 pi into f whole square. Clear? So therefore what you can write it now? Here 1 by 2 into ml square by 3 into, therefore 4 pi square f square. Therefore this is 2. So what you can write it now? 2 by 3 ml square pi square f square. 2 by 3. So 2 by 3 ml square pi square f square. Therefore this is your answer. First option will be your correct answer now. Clear? Now we'll see one more question here, no? Right? If you are able to solve the problems, then only you will be perfect in the physics, no? So you need to understand the problems very clearly. So apply simple rules, that's all, right? So here moment of inertia and the wheel of moment of inertia is given. Moment of inertia is given, no need to calculate. I is given. How much I is now? It is nothing but a 10 kg meter square. Clear? It's rotate at a 10 revolution per minute. Revolution per minute, it is omega frequency. Revolution per minute is a frequency, not a omega, right? So therefore what will be the frequency? Initial frequency is how much? No? Therefore 10 RPM. Therefore rotation per minute means 10 by 60 hertz. RPM, rotation per minute. So therefore here you can write down frequency is nothing but a 1 by 6 hertz. Initial frequency. So initial angular velocity is how much? No? Therefore 2 pi into, therefore initial frequency. So 2 pi by 6 radian per second. This is your initial angular velocity. So what we have to calculate the work done in increasing its speed to 5 times of its initial value. That means 5 omega final, it will be how much now? 5 times of your initial value. Now work done by all the forces, no? All the torques, no? Is nothing but a change in kinetic energy. So what you can write now? Work done. So final kinetic energy half I omega final square minus omega initial square. Clear? So omega final is nothing but a 5 times of this, no? 1 by 2 I 5 omega initial whole square minus omega initial whole square, right? Clear? So therefore here you can rewrite it as, so 5 square 25 minus 1 24. Therefore 1 by 2 moment of inertia is 10, it is SI unit, no? So therefore it is into 24 into omega initial square. Omega initial square. Therefore it is how much now? It is 12. So 120 omega initial is how much now? So 2 pi by 6 whole square. Clear? Omega initial. How we got 24 no? Therefore 5 square 25 minus 1, therefore 24. So what you can write it now? 120 into, therefore 4 into pi square by 6 into 6. 6 ones are 6 20s are. So therefore here it will be how much now? Here 3s are, therefore 10s are. Therefore 10 by 3. So this also pi square value can be taken as nearly 10 value. So therefore you can write it as 10 into 4 into 10 divided by 3. that means 400 by 3. Therefore, how much I'll get it now? 400, nearly 130, 131, right? So therefore, you can expect the question answer nearly 131.6. You can get it now. Therefore, this many joules. Try this one. No? Clear? In this way, you can rewrite it as. Therefore, we'll do one more question here. No. A spherical solid ball is there, solid sphere. Okay. So therefore, is rotating. We want to calculate kinetic energy of the rotation. Kinetic energy, very simple formula, that is nothing but a half I omega square. Moment of inertia of the solid sphere. Solid sphere is what? Solid sphere is nothing but a 2 by 5. Right? Solid sphere. Right? I already taught this one. No? So therefore, here it will be 2 by 5 mr square will be your moment of inertia of a solid sphere now. Right? So how much it will be? Therefore, you can calculate 2 by 5 m is how much now? M is nothing but 1 kg into radius is how much now? 3 centimeter. So therefore, 3 into 10 the power of minus 2 whole square. Clear? How much it will be? Therefore, 2 by 5 into 9 into 10 the power of minus 4. So this will be your moment of inertia. So it is rotating with a 50 radians per second. 50 radians per second. So be careful, 50 radians per second, not rotation per second. Radians per second means it is nothing but a angular velocity is given. Therefore, omega is given as 50. Right? So therefore, kinetic energy can be written as, that is half into 2 by 5 into 9 into 10 the power of minus 4 into omega square. Omega square is nothing but a 50 into 50. Clear? So these two to cancel here, no? Therefore 5 and 10 can cancel, no? So therefore these two zeros, no, it will go off. So therefore 9 5s are 45 into 10 the power of minus 2, that means 0.45 joules. 0.45 joules. Therefore this it will be your answer. Third option. Clear? Now you can solve one more problem, no? Let us see here, no? Therefore, here moment of inertia of the wheel. So already is given moment of inertia, no need to calculate. I is given directly. How much now? 1000 kg meter square. Clear? At a instant, the angular velocity is 10 radians per second. Angular velocity. Initial angular velocity is how much now? 10 radians per second. So after the wheel rotates through an angle of 100 radians, its angular velocity increases to 100 radians per second. Calculate the increase in rotational kinetic energy. Increase in rotational kinetic energy does not depend on directly. You can calculate it as change in kinetic energy. That's all, right? So therefore, here work done or increase in rotational kinetic energy only is asking now. So what is the increase in rotational kinetic energy? That means kinetic energy final minus kinetic energy initial. So 1 by 2 into I into omega final square minus omega initial square. Therefore 1 by 2 I is how much now? 1000. Therefore omega final is nothing but 100 square minus 10 square. Therefore what you can write it now? 1000 into, therefore a square minus b square means a plus b into a minus b. Therefore that is nothing but 90 into 110. Clear? So then you can solve it now. Therefore it will be 45 into 11 into 10 the power of 4, right? 45 into 11 into 10 the power of 4, right? 45 11 means 594 495. So therefore it will be 495 into 10 the power of 4. If you write it now, 4.95 into 10 the power of 6 joules. So first option will be a correct answer. Clear? So here you can solve a lot of problems, no? So you can use therefore it is given as angle, it is given, no? Therefore you can calculate after how much time it will be reaching on to this or no, what will be the alpha value, number of rotations, right? This all the things no, you can calculate it by just rotational kinematics equations. No, you can use it, you can solve the problems. Clear? Like this, from one problem, no, therefore you have to think more number of problems, right? So more like a paragraph type questions, no, like you need to solve it. No, therefore in that given parameters only you try to calculate different things. A wheel is rotating about its own axis. Now we want to calculate the moment of inertia. We want to calculate. So the speed, its speed is 30 radians per second, rotations per second, radians per second. Most of the students know, they will confuse in this one, no, that is radians per second is nothing but omega, rotation per second means is nothing but a frequency. Clear? So here omega is already given, omega, therefore 30 radians per second. Clear? Kinetic energy, it is given as like a 300 joules. Simple thing, no? Therefore, now kinetic energy, what is the formula? That is nothing but a half I omega square. So that implies kinetic energy is given as how much now? 300, 1 by 2 I into 30 into 30. Clear? 30 into 10. This will get cancelled out, no? Moment of inertia is nothing but a 2 by 3 kg meter square. So 2 by 3. You can add one more question. What will be your angular momentum? No, angular momentum is nothing but I omega. I is how much now? 2 by 3 into omega. Omega is nothing but 30. So how much now? 20 kg meter square by second. Clear? So here like that, it is not given, but we are calculated now like that. So you need to calculate different things now. Now let us see. Right? So let us see this question now. There is a disc of mass m and radius r is rolling. Okay, rolling actually. Therefore, rolling is nothing but a rotational plus translatory. Okay, actually rolling question has come, right? And with an angular speed is omega in the horizontal plane. Is asking magnitude of angular momentum. It is a different question, no, not related to this topic, no, but we will do this. Actually, this question is about angular momentum, no. So very simple one, no. Therefore, angular momentum, what is the formula? That is nothing but a right momentum or momentum into perpendicular distance plus it is also rotating, no, translatory, rotational angular momentum. Clear? So therefore translatory, so angular momentum, therefore it is rolling, no. Rolling means what will happen now? It will be having velocity. So velocity is nothing but a r omega. So due to the translationally, therefore the momentum it is then, no, angular momentum. So momentum into perpendicular distance. This is having mass m. So mv into perpendicular distance plus, therefore it is rotational now. Therefore rotational is nothing but a I omega. Clear? So this it will be your I omega. So mv, so m into v is nothing but a r omega into perpendicular distance. What is the perpendicular distance here now? Perpendicular distance here now nothing but a r plus therefore here y plus, no, because here we are calculating, no, this is your vector onto this one, no, radius vector. You have to use right hand thumb rule, radius vector, and this v, therefore it is inside, and this also rotating, no, therefore also inside. So therefore due to the rotational, so it will be acting in the inside only, and also our due to this linear motion, no, also it is acting inside. That's why we are adding on to this. If not, we would have subtracted, no. So therefore now I omega, this disc is there, disc is rotating now. Where is rotating? At this point now. Disc moment of inertia is how much now? mr square by 2 into omega. So it will be omega here. So what you will get it now? Therefore mr square into omega, this r into r, plus mr square into omega by 2. So 1 plus 1 by 2 is nothing but a 3 by 2 mr square into omega. So 3 by 2 mr square omega. This is your angular momentum of this disk now, right? So this is one different question. I already did angular momentum full concept onto this one, no? Therefore, please go through it, that video based on the angular momentum. Now, we'll see. Now, therefore, here there is a uniformly smooth pivoted rod, no, at one of its end released from rest. It is swinging in the vertical, maximum speed of the particle at the end of the rod. So that means what is this question now? There is a one rod, there's one rod is there. So we are keeping like this. Therefore, here we are keeping, right? So here your axis of rotation. Therefore, suddenly released. So released means what will happen when it's come down. Therefore, what will be the speed of this particle we want to calculate when it is at horizontal. Therefore, here when it is coming here, no, therefore it is comes to here, no, vertically here, no, this point P. Point P, it is going with a speed, it is V. So V is equals to what is the formula? R omega. Clear? So we want to R is nothing but this distance, no, this distance is L. So that is nothing but V is equals to L into omega. We want to calculate omega. So therefore, you can calculate, you can by using like a torque concept, no, also you can calculate the omega, or you will use here kinetic energy into this one, no. Now, I already did this question, no, in the torque concept, no. Please go through it, no. Like that also you can do it, no. But we are discussing only rotational kinetic energy, so we will use kinetic energy here. Now here like this is there, therefore when it's coming here, no, therefore what happened now, this height it will be getting decreased. So height is decreasing means what will happen now, potential energy is decreasing. So that potential energy decreasing, no, converted into like a rotational kinetic energy. So what is the decrease in potential energy now? So here it will be your, this is a uniform rod, no, this mass it is concentrated at this point. So this it will come to here, no, therefore how much potential energy is decreased now? It will be L by 2. Therefore, loss of potential energy, right? So loss of potential energy, it will be equal to gain of rotational kinetic energy. Clear? So loss of potential energy is how much now? mg into what is the height loss, no? Therefore it is nothing but a L by 2. So therefore 1 by 2 I is nothing but a rod. Therefore this rod is there. What will be the moment of inertia of the rod now? That is nothing but a ml square by 3 into therefore omega. Clear? So this 2 cancel now. Therefore this m and m get cancelled now. L and L get cancelled now. Therefore here omega can be written as like a 3g by therefore L. Clear? These 2 cancel, L cancel. So this is L by 3. This is 3g by L. Okay. So therefore what you can write it now? V is equals to the point at this point now, L into omega is nothing but a I omega square. Therefore, so it will be the omega is equals to root of 3g by L. Therefore, so omega it will be equal to how much now? Root of 3g by L. So this L also you can take it inside now. Therefore 3g by L into L square. This will get cancelled. Root 3gl will be your maximum velocity of this point, no, at this point. Therefore, so second option will be your correct answer. Clear? Right? So now we'll see one more question here, no. Right. A uniform rod of length is there, no. This is released from rest such that it rotates at a smooth pivot. The angular speed of the rod when it is become like a vertical, right? Angular speed omega we want to calculate. So what will happen now? Therefore, here we'll see this one, no. Therefore, when it is released, here till now we discussed at this point, no. Now it is at this point. So that means it is released like this. Clear? So now it was there, no. It is released like this. So when it is released like this, no. Therefore, we want to calculate the angular velocity. Therefore, what will happen now? When it comes to here, no, like this, final position it will be there. Clear? So we want to calculate again the same thing, loss of potential energy. This distance is L by 4. this total it will be equal to L. This total distance was L. This it will be a center of gravity, therefore this it will be the L by 4. Clear? So now this it will comes to here. So what will be the loss of potential energy? L by 4 only. Clear? So then again same concept, no? Loss of potential energy it will be equal to gain of kinetic energy due to rotation. So loss of potential energy how much, no? Therefore mg into this distance is how much, no? L by 4. Now 1 by 2 moment of inertia into omega square. Moment of inertia where it is rotated now? At this point. Now here at this point we want to write it now. Moment of inertia I. This it will be your Ig. Ig you know it now, ml square by 12. This distance is nothing but L by 4. Clear? I is equals to parallel axis theorem. Therefore that is nothing but Ig plus md square. Ig is how much now? ml square by 12 plus m into L by 4 whole square. ml square by 12 plus ml square by 16. Clear? ml square by 4 you can take it common. 1 by 3 plus 1 by 4. What you will get it now? That is 7 by 4 into 12 into ml square. Clear? So this is multiplication, addition onto this. Now you can rewrite it as mg into L by 4. It will be equal to I. M is how much now? 7 by 4 into 12 ml square into omega square. Right? This is m. Therefore here m and m get cancelled out, no? Therefore this 4 and 4 get cancelled out, no? This 1 L line get cancelled out, no? How much it will be? Omega square. This is 24 taken here, no? 24 G by 7 L, and you can rewrite it as root. Right? 24. So you can take it as here 2, no? Therefore 2 if it is inside onto this one, or you can rewrite it as therefore here into G by 7L 4 taken out, no? It will be nothing but 2 into 6 G by 7L. This it will be a correct answer, first option. Right? We will see one more question now. Clear? Now right, there is a light rod carries a 3 equal masses. These are the 3 equal masses are there, A, B, C, right? Equal masses. Suppose it is m, therefore it is m, it is m, right? So what will be the velocity of the B? Therefore it is B. So in the vertical position, that means this B it will come to here. This is your B, therefore we want to calculate velocity of this B. So just now we discussed now velocity of the B, how it will be. So that is nothing but r omega. Correct? So therefore r omega, what is this r? R is nothing but L by 3 plus L by 3, therefore 2L by 3, therefore 2L by 3 into omega. Now again the same story, we have to calculate. So omega, but here slightly different here, no? Let us see. So now it is a light rod. Light rod means what? Therefore this rod is having, does not have any mass onto this, right? So again loss of potential energy, it will be equal to gain of kinetic energy due to rotational. Clear? So loss of potential energy. What is the loss of potential energy? This particle is having some loss here, no? This particle is also having some loss here. Clear? So these 3 particles is having the loss of energy. So what will be the loss of energy? First one, no? Mg into first particle. Therefore what is the distance, no? L by 3 plus second particle potential energy loss no mg into therefore 2L by 3 plus third particle mg into therefore it is L, right? It is L. Why? Therefore L by 3 plus L by 3 plus L by 3, that is nothing but a, okay, we can write down 3L by 3, clear? So it will be equal to therefore kinetic energy. What is the kinetic energy? Half. So half I omega square, I in, okay, right, here we will write no, therefore here half I omega square. Let us simplify this one no, all denominator 3, so 3 plus 2 5 plus 6, therefore 6 mgl by 3, so therefore it is 2, therefore 2 mgl half I omega square, therefore half I omega square. Now our main intention now you have to calculate I. What is I here now? I is equals to mr square, therefore here this is a particles no, so m into therefore L by 3, so whole square plus m into this perpendicular distance is how much no, 2L by 3 whole square plus m into therefore 3L by 3 whole square, clear? So this is your moment of inertia of these three particles no, so therefore ml square by 9 plus 4 ml square by 9 plus 9 ml square by 9, so all denominators are 9, 9, 10, 14, 14 ml square, clear? Therefore 2 mgl it will be equal to 1 by 2 into I value is how much now? 14 ml square by 9 into omega square. Now we can cancel it no, this m and m get cancelled out no, 1L get cancelled out no, so therefore here 2 1s are 2 7s are cancelled, right? So therefore here what will be the omega square no, therefore here 9 2s are 18g by therefore 7L, this it will be your omega square, omega L you want to calculate. So therefore you can apply the root here no, you can apply the root here. So what you can get it now, therefore at this point, so therefore it is 2L by 3 into omega is nothing but a root of 18g by therefore 7L. So take this one inside and simplify as per your given requirement no, you can solve it. So whatever this answer is asked, right, this it will be your answer, clear? Now again the same type of question no, so similar type of question, right? See, if you goes on doing like a similar type and slightly change onto this one no, so that you can solve the problems and you can remember for longer time onto this, clear? So these all are simple questions and the basic questions onto this. Let us see here, clear? Therefore here thin meter scale is placed here no, therefore and is allowed to fall the velocity of the upper end and to hit the, this already we solved no, therefore like this no, therefore it is releasing. So why? Therefore the potential energy, the loss of potential energy, it will be equal to gain of potential energy. Just now we solved this problem no, so we got it as like when you release this one no, so what will be the velocity at this point no, that is we got it as root 3gl, correct? So at this point no, therefore it will be root 3gl. So try this question no, so that you can understand very clearly, right? So I think, right, check it now. I already did exactly the same, loss of potential energy will be equal to gain of kinetic energy onto this, clear? Velocity only we want to calculate. Therefore here on the power output, okay, so power is given. What is the power no? Power is given 200 HP, that means horsepower. Listen carefully, horsepower. So therefore 200 horsepower means no, therefore 200 into 746, 1 horsepower it will be equal to 746 watt. So this conversion is required compulsory because watt is a SI unit. So he is asking the torque, therefore power is equals to torque into omega. Therefore, omega is given 600 rpm, sorry, 600 rpm. rpm means again frequency, right? So again frequency it is there, no? This is 600 rpm, right? So now this is your 600 rpm. rpm is nothing but a frequency. So frequency is given how much, no? 6000 rpm by 60 hertz. Therefore get cancelled. It is 100 hertz. Omega is how much now? 2 pi into f. So 200 pi. So you can substitute it, no? Therefore we want to calculate the torque. So torque is equals to power by omega. Power is how much now? 200 into 746 divided by, therefore 200 pi. Clear? So therefore 200 get cancelled. 746 divided by pi. Pi means 22 by 7. Therefore this many Newton meter. So try to solve this problem, no? Solve this. So it's a very simple one, no? Simple mathematics. Clear? Now we'll see one more question here, no? Right. A flywheel is the shape in the ring, no? Therefore its mass is given, radius is given, rotating with 5 by pi about an axis perpendicular to its plane passing through the center. So that means here it is like a one ring it is there. So therefore at the center, no? Clear? So here calculate kinetic energy. These all are simple questions only. So but try to practice so that you will get thorough in that formulas, right? Therefore now kinetic energy, what is the kinetic energy? Half I omega square. So first you have to calculate I. What is I? Ring is how much, no? This is one ring. Therefore moment of inertia of the ring is nothing but a mr square. This I did in our moment of inertia second part video. So please check out that. So moment of inertia it will be equal to mr square. So m is how much now? 0.2 into r is how much now? 10 centimeter. 10 centimeter means how much now? 0.1. That means 10 to the power of minus 1 whole square. So 2 into 10 to the power of minus 3 kg meter square. Clear? So therefore moment of inertia I got it. So here he gave, this is your frequency he gave, revolutions per second. That means frequency. The frequency is nothing but a, so how much it will be? 5 by pi. Right? Omega is how much now? 2 pi into f. Therefore 2 pi into 5 by pi, it cancel out, no? 10 radians per second. Now 1 by 2 into 2 into 10 to the power of minus 3 into, therefore 10 square into 100. Therefore these two get cancelled out now onto this. So 10 to the power of minus 1, that means 0.1 joules. Sometimes they may ask you angular momentum, no? Same thing, multiply the both of this or no? 2 into 10 to the power of minus 3 into 10, therefore 2 into 10 to the power of minus 2. So kg meter square by second. Clear? So in this way you can solve the problems. I think, see, after solving this type of questions, no, you will understand, right? So therefore this kinetic energy, work energy theorem, power formulas are there, no? That you will remember for longer time now, right? So now let us see this question now. Right. There is a motor rotates a pulley of radius, no, at 20 rpm. The rope is wound around the pulley, lifts 50 kg block. What is the power of the motor? So therefore what is the torque here now? Therefore now there will be a 50 kg is there now. It is lifting, that means here it will be 500, therefore here it will be the tension, it will be equal to 500. There is no acceleration, he did not mention any acceleration here. So due to this tension, no, therefore they are exerting the torque here. So what is the torque here now? Torque is nothing but a tension into radius, perpendicular distance. Clear? Tension is how much now? Tension is nothing but a 500 into radius is how much now? 25 centimeter. 25 into 10 to the power of minus 2. So these two zeros get cancelled out now. Therefore, it will be 125 Newton into meter. Torque I got it, but I want power it is now. Power is what? Torque and omega. So he gave 20 RPM. 20 RPM means what? Again frequency. Therefore, frequency is nothing but 20 by 60 hertz. Therefore, 1 by 3 hertz. So what is omega? Omega is nothing but 2 pi into f. So 2 pi into 1 by 3. Therefore, 2 pi by 3. So will be your omega. Clear? So torque how much now? Therefore 125 into therefore 2 pi by 3. Therefore this many watts. Clear? In this way you can solve the problems no of related to this. Clear? Now we will go for one more question here no. Right. What is the work done in increasing the angular frequency of a circular ring of mass no and radius is given from 10 rpm to 25 rpm. You can use work energy theorem. So here is given initial frequency 10 rpm, 10 by 60 hertz, that is nothing but 1 by 6 hertz. Final frequency is how much no? 20 rpm, 20 by 60. Therefore here 2 by 6 hertz. Initial angular velocity is how much now? 1 by 6 into 2 pi. Therefore 2 pi by 6 and final angular velocity is how much now? 2 pi by 2 by 6. Therefore it will be 4 pi by 6. Clear? So again it is a ring is given now, moment of inertia you can calculate it now. Therefore it will be mr square, you can calculate it now. And again work energy theorem, you can write it now, work energy half I into omega final square minus omega initial square. I already did this concept now, right? Please solve it so that you will get a practice onto this. Clear? So we'll go for some more difficulty level questions no. Let us see. Yeah. So this is slightly difficult, right? So if you understand the question no, there is nothing difficulty it will be. So there is a let us see complicated question. A uniform bar of length 6a, therefore total length is how much no? 6a. Mass is how much no? 8 m. Mass of this one no? Totally 8 m. Lies on a smooth floor like this, it will be lies onto this. Right? There is a 2 point masses of m and 2m. Therefore this is m and 2m are moving with the horizontal plane. Therefore v and 2v, this diagram is shown, and stick to the bar after the collision no. Calculate the velocity of the center of mass first and angular velocity about the center of mass and total kinetic energy just after the collision. Clear? There are 3 questions are there in this one no. So first you should understand this question here no very clearly. So there is a one rod is there now, this is totally 6a. Everything is there in the diagram now. Therefore this is 2m going with a speed v, is hitting at this point 2a distance no. So this is how much now? This is m 2v going on to this, hitting on to this one now. Therefore when it is hitting like this, what will happen now? This one now, if suppose this momentum is greater, this compared to this one now, therefore this object would have moved like this, right? If this momentum and this momentum both are same no, therefore this will not experience any force no, therefore it will be able to rotate. So now definitely it will rotate no, but whether it will move or not no, we have to see it no, right? So then if it is rotated is there, so we will have a rotational kinetic energy. If it is having motion, translator motion is there, translational kinetic energy and rotational kinetic energy, both you have to calculate. First of all you have to check it whether it is undergoing like a translator motion or not. Translatory means momentum, rotational means angular momentum, right? Translatory means force, right? Rotational means torque. Clear? Keep in mind. So translator, first of all you have to calculate velocity of the center of mass, total body of this one. So therefore what you have to calculate? You have to calculate the conservation of momentum. So what is the momentum here now? Initially this rod was not moving, first one, no? So conservation of linear momentum. Linear momentum. So that means total initial momentum and final momentum, right? We will test the conservation of linear momentum now. So therefore total before initial momentum and therefore final momentum now, final linear momentum. So initially this rod was not moving, rod momentum was 0, and this momentum is having how much now? 2m into v, but it is going in this direction now. Suppose if you take it as this direction now, so this is minus j cap, clear, and this is going plus m into 2v, but it is going upward, therefore it will be plus j cap. So this rod was not moving, therefore now finally it is moving. What is it moving now? Therefore 2m, mass of this one is getting stuck to this one, no? Plus m plus rod mass is 8m into velocity. After this one, no, what will be the velocity? So surprising result, 2mv minus j cap, 2mv plus j cap, no? So minus j cap plus 2mv j cap, therefore it is 11m into v, velocity of the center of mass. So this it will becomes to the 0, 11mv. So velocity of the center of mass, it will becomes to the 0. That means velocity of the center of mass is becoming to the 0, means what? This rod is not moving, no translatory motion, no translatory motion. No translatory motion means what? Kinetic energy. Kinetic energy due to translational is also 0. Therefore it is not moving, right? So but it will rotate. Let us see now. Now, so for translatory linear momentum conservation, no, for rotational angular momentum conservation, no, right? Let us see. So how angular momentum now? Let us see in this one, no. So now net torque, right? So second one, no, conservation of angular momentum, clear? Conservation of angular momentum. So angular momentum, what it will do now here? Therefore initially this was not rotating, total initial angular momentum, total final angular momentum now. Initial angular momentum, so this rod was not rotating now, initially angular momentum was 0, but therefore this what it is doing now, this 2mv momentum is how much now? Therefore 2mv, but what is the perpendicular distance? It is a, but this 2mv what it is doing now? This 2mv, suppose here this is now, this 2mv is comes and hit onto this. So here, see here, if you are hitting onto this, this rod is rotating like this, and this part, no, therefore this also hitting, no, is hitting like this. So this also it is making the rod to rotate, therefore both are acting in the same direction now. Therefore here 2mv right. So 2mv into perpendicular distance is nothing but a. So therefore it is rotating like this. This is making to rotate like this, clear, anti-clockwise, and this also is making to rotate like this, no, plus this is m into 2m, therefore 2mv, also perpendicular distance is how much, no? Perpendicular distance is nothing but 2a, clear? It will be equal to, right? So therefore it will be rotating. What is a moment of, what will be your angular velocity here, no? So that is nothing but I omega. What is I? Therefore your rod is rotating, no? Therefore it is rotating at the center here, no? Center means ml square by ml. L is what? L is nothing but totally, it will be totally 6a whole square. Therefore total mass of this one is how much, no? 8m divided by ml square by 12. 12 plus this mass, therefore 2m is getting stuck to this one, no? 2m into distance is how much, no? That is a square plus this is mass is how much, no? M into distance is how much, no? 2a whole square. This it will be your moment of inertia into omega, I omega. Clear? So therefore this how much now? It will be 2 MVA, 4 MVA, 4 plus 2, therefore 6 MV into A, it will be equal to, therefore here 4 2s are, therefore 4 3s are. So this one you can rewrite it as, this is 2 into 6A into 6A divided by 3 plus, therefore 2MA square plus 4MA square into omega. Let us simplify this one, no? Right, 6mv into a, it will be equal to 3 1s are, 3 2s are. Therefore here it will be 4, 24a, 24 plus 6, no? That is nothing but 30. 24 plus 6, no? 30. Right? 30, sorry, here it will be 2m, m, 30 ma square into omega. Clear? So therefore here what you can write now, 6 1s are, 6 5s are. So this m and m get cancelled out, no? So this and a get cancelled out, no? Omega it will be equal to, therefore v by 5. This is a, 5a. So this it will be your angular velocity of this one. Clear? So now we want to calculate, it is having angular velocity, but therefore it will be having total kinetic energy. Total kinetic energy means what? Rotational kinetic energy will be there. So what will be the rotational kinetic energy? So here kinetic energy, it will be equal to half. What will be the moment of inertia? What we got it now? 30 ME square we got it now. This is simplified, no? Therefore 30 MA square into, therefore here omega square is nothing but a v square by, so 25 a square. This will get cancelled out, no? So this it will be the 15, 5 3s are, 5 5s are. Therefore 3 by 5 mv square will be your kinetic energy of this rod. In this way, see, one question now, you need to understand, then you can solve very easily onto this. Clear? So in this way we can solve the problems, no? If you really understand, it's a very simple one, no? Now let us see one more question here, no? Okay, this the moment of inertia of the wheel of radius is 20 centimeter wheel, right? 40. Therefore here moment of inertia is given. What is the moment of inertia is given now of the wheel? So that is 40 kg meter square. Clear? So its radius is also given now. How much now? 20 centimeter. That is nothing but 0.2 or 2 into 10 to the power of minus 2 or 0.2 meters. So upon to this wheel, no, therefore there will be a one tangential force is acting on this one, no. So tangential force is nothing but like a radius onto this. So this tangential force will create one torque. So we want to calculate kinetic energy after 4 seconds. 4 seconds time is given, no, 4 seconds, right? So we want to calculate kinetic energy. Kinetic energy means I omega square. Omega we want after 4 seconds, no, what will be the omega? Very simple question now. So let us see here. So we have to calculate the torque, no? Torque. What is the torque formula? Force into perpendicular distance. Perpendicular distance. And this it will be equal to I alpha. Clear? So alpha value you can calculate now. Therefore I is how much now? 40 into alpha. It will be equal to force how much now? Force it will be equal to 80 newtons. So 80 into perpendicular distance is how much now? perpendicular distance is nothing but radius. Radius is nothing but so 0.2. Therefore, here alpha is equals to 80, right? That means 8 into 2 divided by 40. Clear? So 4 2s are 4 10s are 2 1s are 2 5s are, or you can rewrite it as, therefore it is 2 by 5. So therefore radian per second square. We don't want alpha, we want omega. So therefore here time is given, no? Omega final, it will be equal to omega initial plus alpha into t. Assume it started from rest. So therefore omega final, you can write down alpha is how much, no? 2 by 5 into 4, therefore 8 by 5 radian per second. So we got it, no? We want to calculate kinetic energy, right? So what is the kinetic energy formula here now? Kinetic energy, it will be equal to 1 by 2. I is how much now? I is, we got it as 40 into omega, therefore omega square 8 by 5. 8 by 5 into 8 by 5. Clear? So therefore this is 24. Therefore 64 into 4 divided by 5. So you can rewrite it as into 2. So 64 into 8 by 10. 64 into, therefore 8 4s are 32, 8 6 are 48, 49, 50, 51, right? Therefore 512 divided by 10 are 51.2 joules. This is your, so total kinetic energy of this, rotational kinetic energy of this wheel, right? Let us do so one more question, no? So very simple one, no? Here the moment of inertia of a disc, no, of an axis passing through the center and perpendicular to the plane is 1. Therefore it is rotating with an angular velocity is 100, and a second disc of same mass and radius is joined coaxially, and these two discs, no, together to continue with a rotate about a same axis, no, and the loss of kinetic energy in kilojoules. So this is exactly the same way how to solve the problems, no? So like collisions. Therefore here there is one disc is there, no? Now this first disc, no, it is having moment of inertia is I1, that is nothing but a 1 kg meter square. So it is rotating with an angular velocity is omega 1, and another one more disc is there, no? Now one more disc of same mass, same radius, no, join. Therefore one more disc is there, no? Therefore these are kept here, no, on the same onto this. Now we want to calculate what will be the kinetic energy of this loss of kinetic energy. So this is and stick together and rotate with the same one now. This is exactly like a two collisions. Now collisions, what two objects are coming and colliding and combining, like sticking one to the, and it is moving like a perfectly inelastic collision now. Like, so in that we studied that what will be the common angular velocity now. We can not only this loss of energy, we can calculate common angular velocity also. That is nothing but I1 into omega 1 plus I2 into omega 2 is equals to I1 plus I2 into omega, right? So you can write down omega is equals to I1 omega 1 plus I2 omega 2 by I1 plus I2. In this way you can calculate what is the common angular velocity, what is the loss of energy now. So kinetic energy loss of kinetic energy we already studied in collisions lesson, no, right? Half we can rewrite it as m1 m2 by m1 plus m2 into v1 minus v2 whole square. But here I1 I2 by I1 plus I2 into, therefore omega final, so minus omega initial whole square. In this way you can solve the problems, no, very easily. You can use our collisions lesson, no, therefore kinetic energy, loss of kinetic energy in collisions lesson. 1 by 2 m1 m2 by m1 plus m2 into v1 minus v2 whole square. So I also did one video on the collisions. No, I will keep in an iCard here. No, therefore if you did not watch, please watch it so that it will be very easy to solve. Here instead of the mass m, here we can write as like a I. Therefore here 1 by 2, I is how much now? 1 into 1 by, so therefore it is 1 plus 1 into 2. So omega is how much now? It is radians per second, directly is given, no? 100. Therefore another one is not rotating, no? Minus 0 whole square. Clear? So how much it will be now? Therefore 1 by 4 into 100 into 100. So 4 means 25. So 2500 joules. He is asked in kilojoules, no? Kilojoules means how much now? 2.5 into 10 to the power of 3 joules, right? So that means 2.5 kilojoules. This is your answer. Clear? Now we will go for one final question here, no? So this is one interesting question. Lot of things are there, no, to learn in this one, no? So final question, let us see them. Here, a person is standing on a platform, right, rotating with an angular speed of 1 rps, right? He stretches his hands and carrying the weight. So on drawing his hands closer to the body, the moment of inertia of this is changes from 8 to this one now. The increase in kinetic energy, this is most important one, no? So also I did, this is lead to the conservation of energy. I already did the question, video on the conservation of energy. So please go through it. So now lot of interesting thing, no? Suppose there is a, what happened now? Here there is a one rotating table is there. This is one rotating table, turntable. This turntable is rotating with an angular velocity is omega 1. That is 1 rps, rotation per second. Now this person now is keeping the hands like this. Then what happened now? He made it to closer here, right? So he made it to close his hands. When he closes his hands, no, what happened now? Moment of inertia decreased. So therefore he will be rotating faster. When he is rotating faster, his kinetic energy is increased. So from where this energy has come? If you really know it, no, please comment it, right? So where this energy has come now, right? Initially he was rotating. It is when he is stretching, no, I1 is a moment of inertia. When he is closing, I2 is a moment of inertia, right? And it will be having omega 2. So closing and this one, no, you can rewrite it as conservation of angular momentum, right? So that is nothing but I1 omega 1 is equals to I2 omega 2. Clear? Now we can rewrite it as, right, on drawing his hands closer to the body, the moment of inertia changes from, so when he stretched now, therefore what is this one now? Moment of inertia 8, so it is came to the 4. Now this is 2 pi into f1, 2 pi into f2. You can rewrite it as I1. I1 is how much now? 8 into 2 pi into f1. F1 is how much now? 1 rps. This how much now? It is 4 into, therefore 2 pi into f2. So this is 2. So frequency will become like a 2 rps, right? So you will be rotating with a double speed onto this. So omega, what will happen now? Omega 2, what will happen now? Therefore 2 pi into 2, therefore 4 pi radian per second. Omega 1 is how much now? Therefore 2 pi radian per second. Clear? So what happened now? Change it in this one, no? So we want to calculate the increase in kinetic energy. That means he is having some kinetic energy K, right? So kinetic energy K2. So therefore here what will be the change in kinetic energy now? So change in kinetic energy, that is nothing but kinetic energy 2 minus kinetic energy 1. So what is the kinetic energy? Half. So I, what is this one now? I is nothing but a 4 into, therefore here 2 pi, that is omega is there, no, that is nothing but a 4 pi whole square minus half into 8 into 2 pi whole square. Clear? So this how much now? It will be 2. This is nothing but a 4. This is 4 pi square means it is 16. 16 into 2, 32 pi square minus, therefore 4 pi square, 4 4 16 pi square. Clear? So 16, therefore you can rewrite it as 16 pi square will be your increase in kinetic energy. That means when it is when you are stretching his hands, no, moment of inertia is large. So therefore when closing his hands, no, moment of inertia is decreased. So therefore he will be rotating faster. So he will be gaining the kinetic energy, right? So where this energy has come, no? So while spreading from here to here, whatever we are doing, that energy, whatever you are losing, that energy, that is converted into like a kinetic energy of this rotating body, no, right? So he is gaining the energy. So by using our muscle power is there, no, muscle energy is there, no, that energy is converted into like a rotation, no. Like this, each and every analysis, no, you have to do it so that you can get the clarity into this one, no. I already did full videos on moment of inertia, torque, angular momentum and work. So please go through it, no, all these concepts, no, thoroughly. So from this one, no, you can expect compulsory 2 to 3 questions in the JEE mains and NEET, right? Thank you for watching. So we'll come with one more new video. So please subscribe to my channel.